As we look to continue to simplify rational expressions that are multiplied together, I've given us a couple examples of what happens when we have a fraction times a parentheses. Well, this parentheses really can be thought of as over 1, and so that's going to help us to realize our problems. So let's write it just like we did in the previous page. 3 over x goes there with the 1 there. Now, this problem, we're going to look for a GCF. We always look for that first. What's the GCF there? I hope you saw that the GCF is x. When we take an x out, we have an x minus 1 left. Now we can cancel now that we've factored the problem. The x's cancel, leaving us with nothing else in the bottom, so my answer is just 3 times x minus 1. I don't need to put over 1 since there is no denominator. My second problem, I'm going to draw my fraction bars again, and my 2x and my x plus 3 are in good shape there. They don't need to be factored. The x squared minus 2x minus 15 is over the number 1. So, we try to look at what are going to be the factors in the numerator. It's very likely that x plus 3 is one of the factors. So, let's think. 3 times what is negative 15? 3 times blank is negative 15. Well, that number has to be negative 5. Now, do these two add to negative 2? They certainly do. So part of our denominator helped us get the answer for the numerator. That's going to be the case in many circumstances. So, our x plus 3's cancel, and we're left with 1's there, which gives us an answer of 2x times x minus 5. And that's our answer on that problem. As we look to the next one, we once again quickly see we have to put it over 1 as our denominator. And that's the difference of 2 squares. So c plus 1 and c minus 1 over 1. Our second half, we can take out a GCF of 3. So 3 times c plus 1. This lets us cancel our c plus 1's. And our answer is, very simply, c minus 1, c minus 2 over 3. As we look at our fourth and last problem on this page, we have to think about what's going to happen here. Are we going to have GCFs? Are we going to have difference of 2 squares? Well, let's write down the ones that we already know. The x minus 5. The others don't look like they're the difference of 2 squares, so let's try to think GCFs. What's the GCF on 4x and 6? Well, that GCF is a 2, which leaves us 2x plus 3. Pretty likely that 2x plus 3 might also occur in the top, so let's look up here. The GCF between 6 and 9 is 3, and once again, what do you know? We have a 2x plus 3. Is it likely that this x minus 5 might duplicate down here? Well, between 3x and 15, the GCF is 3, and leaves us with an x minus 5, and so our suspicions are true. And the x minus 5's cancel, the 2x plus 3's cancel, the 3's cancel, and all we're left with on the top is a 1 and a 2 on the bottom. So, look to see if the problem can help you solve itself by giving you some of the hints.